Heat a pot to a glowing 1500 degrees, fill it with molten metal, pour, and let it cool. Then do it again every shift. An ordinary refractory crucible crazes and cracks within a handful of cycles. The dark cylinders here are cut from silicon carbide to take that punishment, heating fast and evenly, and riding out the thermal shock that splits lesser pots. Open with the way it moves heat. Silicon carbide carries warmth like a metal, a thermal conductivity many times that of an ordinary refractory. So the wall heats through quickly and evenly, melting a charge faster and on less fuel, with no cold spots to leave the metal uneven. Strength holds alongside. Oxidation, corrosive slags, and aggressive fluxes leave the wall intact across long campaigns, and molten metal does not wet or cling to the surface. So the melt pours clean and the crucible gives nothing back to contaminate it. Surviving the furnace is really about thermal stress. When a wall heats unevenly, the hot and cold zones pull against each other, and the stress rises with the material's stiffness, its expansion, and the temperature gap. Silicon carbide barely expands and conducts heat quickly, so that gap stays small and the stress stays low. Letting one crucible hold metal up to around 1600 degrees and take rapid heating and cooling that cracks ordinary pots. That margin shows up over time. Where a plain refractory pot can split within 10 or 20 heat and pour cycles, a silicon carbide one rides through far more, holding its shape and its seal campaign after campaign. Fewer cracked pots, fewer lost charges, fewer cold starts. Sizing starts from the melt. Capacity is set by how much metal a heat needs. From a few hundred grams in a small cylinder to tens of kilograms in a tall one. With the bore, height, and a wall around 8 to 12 millimeters chosen to heat through evenly and stand up to the charge. From there, the shape follows the furnace. Outside diameter to the coil or pit, height, wall thickness, an integral pouring lip, and the base profile are set to the melt, the handling, and the way it sits in the furnace. Each one cut to a drawing rather than a stock pot. The work these cylinders are built for is metal melting. The foundry and casting furnaces that melt copper, brass, aluminum, gold, and silver, heat after heat. Set into an induction or fuel-fired furnace, the crucible couples to the heat and brings the charge up quickly and uniformly, so the metal melts sooner and the temperature stays even across the pour. The non-wetting wall releases the melt clean and keeps slag and flux from eating in, and because it rides out the thermal cycling, the same crucible runs campaign after campaign before it needs replacing. What comes out of the pour is metal at temperature, uncontaminated by the pot that held it.